All right, welcome everyone. Today we're going to explore one of the most important topics in engineering drawing, projection of lines. Now, before even we start drawing, let me ask you something. When you look at an object in real life, maybe your phone, your laptop, or even your desk, do you just see one side? Or do you see multiple sides at the same time? Exactly. You see multiple sides. That's what we call a pictorial view. Why you can see height, width, and depth of all at once. But in engineering drawing, we don't draw objects the same way we see them in 3D. We convert them into 2D views. And that process is called projection. So projection is simply the process of taking a 3D object and representing it using 2D views. So in today's lessons, we are going to understand how this works, especially when dealing with lines in space. And instead of only imagining or sketching, we are going to use AutoCAD. In this case, I'll use AutoCAD 2027 student version to visualize, construct these projections. This session will be divided into two parts. First, we'll take a practical introduction of AutoCAD that you may understand, the interface tools and how we actually draw. And then we move into example-based learning, where we'll solve projection problems step by step. We'll begin with two simplest orientations of a line. In the first two orientations, you know very well, perpendicular to the horizontal plane and parallel to the HP. And when a line is perpendicular to the vertical plane and parallel to the horizontal plane. So to make things easier to understand, we'll use a standard length of, say, 40 millimeters in today's examples. This will help us focus on how the line behaves instead of getting distracted by different dimensions. So by the end of this lesson, you should be able to look at a projection problem and immediately know which view shows the true length and which view collapses into just a point. Once you understand that, projection of lines becomes very simple. So let's get started. We'll begin with a quick introduction to AutoCAD. Okay. All right. Now we are moving into a very important part of the course. We are going to start working with AutoCAD. Okay. For this study, I'll be using AutoCAD 2027. As you can see, it's a student version. What you can see on top of it, before I get to walk you through, do not focus on the problem that we're going to solve later. It's just back here, but I just want to walk you through in order for you to understand what AutoCAD is all about. Okay? And now pay attention. Just like any other program on your computer, AutoCAD is very easy to open. You can simply locate the AutoCAD icon, double click it, and you're good to go. Not complicated, just like opening Word document or Chrome, another application. Now, I have already opened AutoCAD here, and so I won't go back to the desktop. We'll work directly from the screen. This is what we call it's not exactly the initial AutoCAD screen, but now this is what you see when you AutoCAD opens, but I've opened a file, and this file is projection of lines, which I've just put some content here for us to learn quickly. But initially, before you get to see anything, it should be something like a new, if I had a new what? A new drawing here, you just but see it, okay? In this case, let me just but add a new drawing here that we used to do what? To demonstrate our learning. Now, now I've created my probably not just a model, it is plain as such. Now I will explain that you may understand before we proceed. So in this case, I'll be changing in between these two files. Well, at first, it might look like a little overwhelming, so don't worry. We are going to break it down step by step quickly. So at least before we start to draw, you get to know what AutoCAD is. Think of this like walking into a workshop for the first time, okay? You see tools everywhere. These are tools, this is your workshop, the entire way, okay? And you're wondering, where do I even start? That's exactly what we are going to solve right now. AutoCAD is basically a digital drawing workspace. Everything you need to for engineering is already arranged here. All these you can see. Okay. Now, I want to start breaking it step by step. Here on top is what we call the title toolbar at the top. This is where you see at the very top we have what we call the title bar. This shows the file name. As you can see, it has not been saved. So basically, you see drawing two. Like as you can see, Word document 1, 2, 3, if it was a Word document. But here, because I had saved the file, you can see the previous file, it's projection of lines. So if we save this one, and you know the process of saving, you just go to the file and just say, or you use shortcut keys, Control Save, and that's it. If it has not been saved, it gives you an option to label the file. Okay. Now this is a new drawing. That's why you see something like a drawing one or drawing two in this case. And below here, what we call ribbons. Okay, ribbons. What are ribbons? Ribbons, for example, which is active. The home ribbon is active. So you go in between by clicking and clicking and clicking all these ribbons. Okay, this is where most of the tools are located. For example, in the home ribbon, you can see several things like line, polyline circle, or blah, blah, blah. All these are under the same. Okay, you notice that they are grouped into tabs. And now these are specific tabs, okay, like home, insert, annotate, parametric. Now this is your drawing area. Large area here is your drawing area. It can be modeled later. You can just change it into grid. For example, if I click grid, it will just change into grid, but like squares or blocks, or, I mean, of like a graph paper. Okay, but I'll do that later. And let me move down. What else? Down here is what we call the command line. Okay, this is where AutoCAD listens to you. Let me show you what we call a command line. Okay, I'll come to exactly explaining here. You can see the command. Okay, if you click a cursor here, let me just do that one so at least you're able to understand what I'm communicating to you. Okay, if for example I click here, now it's active. If I click L to start with the command, let's say I'm typing a line command, it populates. Okay, you may not be able to see, but it says a multi-line or whatever it is. You can L as line and press enter, and it says specify the first line. I can just take anywhere in the work area. I click there, and it shows I'm drawing a line. The line I can later I'll show you how these other tools. We are moving to the next important part, so you can just draw a line, and you can draw and you can close, and that's it. Okay, basically that's our command work using the command line, or you can just go straight away here and pick the tool that you want and to just draw. I'm just running quickly so at least we understand what we want to work on. Okay, now wherever you type a command, it appears there we have just seen, and wherever AutoCAD needs an input, it asks you as you just say, as you saw. Now, I've demonstrated that one. Here below is what we call the status toolbar. Status toolbar. This control how accurate you draw. And I want you to pay attention when I say accurate you play. For example, we have what we call the auto mode here. Okay. Let me just explain. Okay. Auto mode. We have the auto mode here. Okay. What does the auto mode do? It it enables you to draw what you call perpendicular on horizontal lines only. For example, it's when you drop in by clicking on it and it's active here. You see? Now, let me draw there. As you can see, the line can only move either. Let me just zoom. Okay, you can move either horizontal or vertical. But if I try to draw it at an angle, it can only snap to vertical or horizontal because this is active. But the moment I go in between and deactivate it, now I'm able to draw. You can see I can give an angle a line. Okay, but the moment I lock it, still it's active. It can only allow me to draw vertical and horizontal lines. Okay, now that's one thing. Two, what does it help us to do? There are also other things that we can learn from this. Okay, and this is what we call object snap. Okay, the object snap, it is. Okay, also the polar tracking object snap, and also the line weight. The line weight it allows us to change in between the thickness of our line to be visible. Okay, and it can be also toggled in between on and off. And further to the end, let me show you. Further to the end of this is what we call another extra customization menu. In this customization menu, you may not be able to see because it's displaying various. Once you click it here down, it's able because it's populating. That's why you're not able to see in the projected screen. But it has some things also extra information like coordinates, model space, grid, blah blah blah. Quite a number of information that you can see. You can see in this projected screen because it's a pop-up and it cannot be visible in the actual screen there. For now, you have your AutoCAD, you'll be able to see that one. Now, for today's purpose, mainly is to enable you understand what I'm going to draw, what it is all about, and I'm navigating in between using AutoCAD. Okay. Further, this is very important. Pay attention to this. This is where we have what you call various items. Okay, before here, let me just talk about this cube. That's what you call right here. That's what you call a ViewCube. On the right side here, you'll see the cube, which helps you to navigate in between 3D and also 2D. Okay. And it's good especially for 3D because you're able to navigate and see. You can click here to change views from do in the actual drawing, the front side, etc. For example, this line, if it's active, you click, you change, and you're able to navigate. And what have I left? Okay, these are navigation tools which are here. You can see further. You can let me hover them so that they're active. Okay. For example, you can see this is zoom, extend, this for rotating, hobbit, and this navigation, what you call a full navigation wheel, for navigating between them, and this for also moving. For example, if I click here, it turns and changes the shape, and I'm able to click down the left part of mouse and move line to, or am I drawing into any given space or wherever it's active. For example, let me just go to the projection of lines here where I was, and I need to move the entire drawing area. You need to see this area. I can just move it, and I can now zoom by dragging up and down the mouse wheel here, and you're able to see perfectly, or just zoom out and out. Simple period. Now, I will shift to the new drawing, which is empty. What else have I left out for you here? Talk about navigation tool, the pan and the rest. Now, what else? We have also what we call down here, one moment, the world coordinate systems. The world coordinate systems are below the world coordinate systems are below, as you can see here. The navigation cube, here they are. And what else have I just left out? Nothing much. And that is, we will now move to another item. Okay, it shows actually basically then what the world coordinate system shows us, or gives us, is basically the world coordinate systems, or it shows the direction of what we call the x and y, which in here down on the right because we are in 2D. If we're in 3D, you can just go show us Y, X, and Z coordinates in 3D. And finally, basically, think out of us as your reference, like knowing where the north is and east, and up there. Later, we can change this into what we call using what we call the UCS. Okay, but for now, we keep it simple. Okay. Now you can see AutoCAD is not complicated at all. It's well organized. Basically, it's well organized. At first, it may look like a cockpit of an airplane, but don't worry. By the end of this lesson, you'll be able to fly this plane personally. Now, we understand AutoCAD environment. Let's move on now. We can actually use it in engineering drawing because I think that's why you are interested mostly. And I'll just go straight away to our working what slide that I've just used. I just want to zoom it, and you can see I've already drawn. I've changed the color here. I'm going to explain to you so that you catch up quickly on what we need to understand about how AutoCAD works. Let me take you back for a moment to manual drawing class. When we are on a drawing paper, okay, you don't use just one pencil, correct? You just use several or different. You usually have different pencils, 2H, 3H, 4H, HB, and also H, among many others, okay, or sometimes B. And you know very well these pencils are used for different, for HB, for dark outlines, H for light lines, and sometimes 2H, very light construction lines, but 4H is the best for that. And sometimes you also use stencils for circles, symbols, or standard shapes. Now, something very important I want you to understand here, okay? Every time you want to draw, like I've just drawn, every time you put down one pencil, you pick another, right? Maybe sharpen it, adjust it. That process takes time and can be frustrating. In AutoCAD, we solve that problem using layers. And this is what we call layers. Layers are under this tab, okay? Under this tab of lines, and these are what you call layers. As you can see, I've just labeled them and changed them now. Each layer has its own color. Here, let me just activate this so you're able to see. Are you able to view this one? Okay. As you can see, it's populating, so it's not, you're not able to see. But if I were to change here, I can just change to a center line is in green, and I can change also to solution here. It changes, but when it's populating, because it's a pop-up, you're not able to see on the screen. But this is how you create. Now, what's the purpose of layers? Let's just proceed again. So instead of you picking and sharpening a pencil every now and then, you simply select a layer. And for you before you select a layer, how is a layer created? By just clicking here on this icon of layer properties, you just click it, and the moment you click it, as you unfortunately it's not able to populate, you're not able to view it, but you're able to select and create different layers upon clicking this one. Once you are on AutoCAD, you'll be able to view that one. Now, I will take you back to what we're going to do today, because in my case, I've just created some different layers for you. Okay. For example, as you can see here down, okay, the XY layer is in red, reference line. Construction layer is just still in light. Here it is as construction lines and also for dimension lines, as you can see. Okay, what is it? The solution layer, which is in blue, is thick and bold. I've increased that we call the stencil, the line thickness. But when this is deactivated, okay, let me just show you what I'm talking about. Some other important tools that you need to understand. Now, as you can see, I've deactivated here on the status toolbar. Watch on my the cursor, where it is here down, the status bar. You can see the status bar moving, the mouse here up to the status bar. Now I'm clicking on this line. This I'm toggling in between the line weight display, LW display. Now, when I click on it, in this active, it shows the density of the lines in the line weight, okay? Because otherwise they remain what you call by default construction lines, not visible directly with the colors I just put there, etc. I hope you've understood. Okay, now I'm gonna deactivate it again, and as you can see here, it was just a line, construction line. You can maybe be able to see the color, but you can't see its thickness. It cannot communicate. So that's why I told you you have to play, you have to draw smart, and those are the advantages of using AutoCAD. Now, what else have I just but said again? Okay, let's go back to where we were. Mhm. Which other tools that I may have not drawn or just shown you? Several thousands and thousands. So think of this uh, as just what you call construction layers: 2H, solution layer, HB, center line, special for stencil. If I had some circular features here, I would have just shown you. Okay, now layers help us to do faster, cleaner, and more professional. And in that case, because we are going to do, I'm going to show you now to proceed. It is a very important introduction that I really need to make for your understanding quickly. Allow me in 1 minute or two to talk about something here. Now, if you understand how we always draw, let's understand what we are drawing today. And that brings us to one of the most important concepts in engineering drawing, the projection of lines. To understand projection clearly, we must first understand something very important: a plane. In engineering drawing, we work with two main planes, especially when we're talking of 2D. Okay? The horizontal plane, HP, and also the vertical plane. In this case, I have drawn just but drawn it just as but there you can just do it. Okay? Now we can take as line this line BA as our vertical line, etc. But that's not a plane. For us to understand what a plane is, just to have what you call more of a service. That's a line, a vertical line. What I've just shown you here are just what you call vertical lines. Okay, a vertical line and an horizontal line. But when we talk of a plane, here the here is a plane for you. Let me just zoom it for you to be able to understand what I'm talking about. Now, I want to zoom it here. We are talking of a plane. Okay. This is our first orientation anyway. I'm going to use that example in order to elaborate on what we want to understand or what we want to learn here. Now, instead of imagining them, let's see them and feel them using the simple things around us. Okay. What is it that you have in front of you? Probably you are using your laptop now to watch this live session. Let's start with something very familiar to you. Your laptop, the keyboard, represent the horizontal plane. Here is, I've just drawn this one and I'm using as what? As a good example, the HP as part of the keyboard of your laptop. In this screen here, the VP represent what we call the vertical plane. Okay? Now, when your laptop is open as such, you see, both the keyboard and the screen are the same, seen at the same time. This is actually what we call a pictorial drawing or presentation, where you can see multiple sides. You're able to see the VP, and you're also able to see what we call the HP at the same time. Just like in drawing space, one is horizontal, the other is vertical. Beautiful. Now let's take this understanding even further. Allow me to explain how you're going to use AutoCAD, but in this case, explain about the planes. Now, imagine you have an A4 paper, okay, the drawing paper, or just take your A3 paper. Now, an A paper measures, what are the dimensions in millimeters? It's 210 or by 297 millimeters, okay? Place it in portrait orientation in front of you, okay? Now, lightly mark the center, okay? Now, let me. I'm gonna use an expression for us to understand. When you mark it at the center, I'm doing this one so that you work with me because you have a paper. Now, fold it clean and straight. Okay, once you fold it in and straight, open it slightly like a book or like a laptop. Okay, you notice the top half is the VP, it's now standing, and the bottom half is lying flat. Okay, like this one, like this example that I've just demonstrated here. So again, we have two planes meeting in at a line and positioned at 90 degrees. And that's why until the sheet becomes flat on the table, you may not be able to, you'll be seeing two views. But the moment it's flat on the table, you are able to see only just one surface. And I'm gonna demonstrate by using this one in AutoCAD. What I'm just trying to just say here. Pay attention to this. Let me draw here. I'm assuming that now I'm zooming it out. You want to extend this line, and I want to change the color of this into red. Let me just an XY line color, and I want to do what? Straight line. This one is an extension of paper. I'm gonna draw what we call another line. I do this one, okay, approximately something like that, okay. And after doing that one, is another one up to that extent. I'm assuming you to see this one that you've just flattened that paper along this line, the edge. And I'm gonna change the color of the edge. Now solution, like, let me just use this point up to that point. And that's why you just done what? Flattened it. It becomes just a flat surface. But if you fold it upwards, it becomes what you call at an angle XY. What we're able to create is just a surface, two surfaces, which one becomes a VP and the other HP. I have completed that introduction. Now, so when we draw in AutoCAD or on a paper, we are actually working on this flattened system. Flattened system, just your A4, A3, or say A0, whichever paper you're gonna use. Okay. After flattening, I've just said again, the vertical plane appears above. Now this way is very important. Pay attention to this. And if I were to turn this one, I want to turn this one here. The flat surface would have just been what? One of this line here, this blue line becomes the XY line here. Let me zoom it so you're able to see, or increase the font size. Here, XY line, the red one. Now, the top part, which is the HP, lies above that one, and also the HP, this one, comes beneath this one. So it should be something like this. Let me just do it for you, understanding. Very simple. It's like a one surface. I'm just gonna use that rectangle to draw a rectangle like that one, and we have two what? Two surfaces. Let me assume that I'm gonna move it so it can be what? Sorry, I'm gonna move this item. Okay, let me just select this rectangle and just move it. And I want us to align it the center. You see one that is active, and I want to align it along that one. So what I've just said, I've just put it along the X so that half of it, the top half, is above the VP, and this one becomes what? It's below the VP. So what am I talking about? It was initially in this manner, and you flipped it, you just turned it in front of you, it becomes one surface, but the VP is here. This becomes the VP, and down here is where the HP lies. Okay, that is my explanation for your understanding. And finally, it becomes a flattened surface. So from now on, wherever you see an XY line, and I repeat again, wherever you see an XY line, this line here in red, don't just see a line. See the intersection of two planes, the intersection of these two planes, okay? These two planes in blue here have been unfolded into one surface, flattened. Repeat again. Don't just see a line, but see the intersection of two, intersection of two planes, VP HP. This is the key to understanding projection. So if a point is above, now I'm explaining for you to understand. If a point is where, let me just exactly come to AutoCAD again here for you to be able to see. If a point I said is above the XY line, its front view, if a point is above HP, yes, its front view is above the XY. I repeat again. If a point is above the HP, this is the HP, above the HP here, its front view is above XY. If a point, for example, is below HP, let me take, for example, this HP. Here, this is a point I've marked here, like a point, okay? It's below HP. If below HP, it's also below what we call the XY. Go to another, pay attention. If a point is in front of the VP, there are terms that we use. You will say, for example, a point is in front of the VP. The top view is below, the XY. The top view is below the XY reference plane. Here, below, here, okay? In this case, it should be somewhere here. Now, if behind the VP, then if I say that a given point is above or behind the VP, always have this visualization that that point can be only drawn when you're doing in a flat surface like this one. It should be drawn above the XY line, the reference line above here. What should I again? So every point has two views, one on the vertical plane and one on the horizontal plane. That's why we use notations like A and A prime. Should I repeat again? Because this is very important. That's why we use notations like what? A and A prime. And A prime. Now I'm zooming for visibility purpose. Okay. And let me just go again. When we use notation to distinguish front view and top view, and these notations can only be labeled as A and A prime, not on the same view, but on different distinguished views. The top view, and in this case, for example, here where we are talking about A, is on what? On the VP, whereas A prime is on the HP. Now that we understand the planes and how projection works, allow me straight away to get ready and apply this to what we call projection of line on what we call just a worked example. We'll begin with the simplest orientation, the foundation. And this is the first orientation that we talked about. Now, projected now here for you. A question that we have that we're going to use for our learning today, and quickly, this would be our first example. And it reads, I'm going to just read for you, a line, it be 4 millimeters long, has a NB 15 millimeters above the HP. So remember the terms I was just talking about: above, below, behind, in front. Okay, we'll be using them a lot. And 25 millimeters in front of the VP. The line is kept perpendicular to HP and parallel to the VP. Draw its projections. Okay, it looks nice here when it has been drawn, but I'm gonna explain to you and work with you through on how to solve this, not to do it. Okay. Now let me erase this by selecting and deleting it because it was not part of the drawing, and I'm gonna zoom it again for you for visibility. So I've just said here, you can see I've given the procedures. First, you draw the Y reference line. Okay, what you do, you just click the line. In this case, I'm gonna work with you because I've just drawn here for you to be able to see, and I will just change this one here and select the reference line. It's red. and then I'm gonna draw it. Now, don't focus on that one. I'm gonna go to the line. I've already drawn, so I'm gonna just draw and do what? First of all, let me lock the other mode here so I'm able to draw some lines. You see this one? I want to toggle in between, so I draw the HP here, and I'm gonna do it longer. Forget about I right click, and once I right click, I enter, and it's done. Okay, this is the line we're talking about. I'm gonna hold it and drag it and move it there. Forget about this one. I just want to walk you the process of doing this. I've already done, and I don't want to label because of time. This is what you call our HP. So the first is to draw the XY reference line. Now I want to assume that this is the XY reference line that we've just drawn. I've just shown you how to draw a line. You just invoke a command down here, the command line, by line. That's one way. As it populates, and you can just press enter and becomes active. As you can see, it says specify the first line, and you just click here anywhere where we want to place it, and again it says specify. Watch here, specify the next point. I can just hover drag it wherever I want, and I can just click there, and I press enter. It's done. Or you right click and select from the pop-up menu as an enter. But I'm gonna now select the two lines. Okay, I'm gonna select the two lines and delete them because already we've drawn the XY reference line here. Here it is. Okay. Now the next step. What is our next step? Very important. Oh, what do we know? The orientation. Let me just say, line is perpendicular to the HP, and the same line is parallel to the VP. It's perpendicular and parallel to the VP. Okay. Now let's solve our first example. We are given a line which is AB 40 millimeters. What does it say? Please pay attention. One moment. One moment. What does it say? One end on B is located. Let me just be very precise to this for you to be able to understand what I'm just talking here. Let me zoom in for visibility purposes here. This is our XY line, and I'm gonna maybe probably increase that line or just for visibility purposes, but it's not necessary here. Not always that it's our what. Okay, let me just say it. Let me just copy this one and paste it here. Okay, and I'm gonna edit this one so that it's visible, and I label it as what? X. Okay, let me delete this one because it's too small, and so for visibility purposes we don't get to struggle. And I'm gonna also copy this one, selecting copying using Control V C, and I'm gonna paste it here, and I'll just delete this one, and I delete it, and I'll just drag this one here, and I double click, and I select, and I change as right, capital Y. That's it. And it seems this one is in lowercase. Let me change it to uppercase for you purposes. Right now it's visible. Our line XY is just back there. Now there's some things that you really need to understand when we are talking about our drawing. One, what do we say? The one end point is located 15 millimeters above HP. One end B, because it's very straight, as we just but again said what we talked about this. Let me just drag it here for our view. Let me zoom it a little bit. Yes, beautiful. It's saying one end, and this end is known as point B. It's 15 millimeters above the HP. Now the question is, how do we get to do that? Basically, the goodness with AutoCAD is that you can just always, you can see just by showing the dimension here is 15 millimeters, and I've already located that point. The point NB is what? 15 millimeters above the HP and 25 millimeters in front of the VP. Remember, what do we say when we talk about a line which is above the HP? Very important. That line, where do we get that kind of line? as you can see, for us to proceed, the very basic things that we need to understand, we have to locate that point because that is given, that is the given end. Now we're going to locate it. B is 15 millimeters above the HP, so it's front view. Remember, I said again, its front view, which would be now B prime, would be 15 millimeters above the XY. Aha. So what are we supposed to do first of all? We need the second step is just to locate point B. So we are going to draw, we're going to draw its front view. So what is our front view here? B is 15 millimeters above. How do we measure that one? Using AutoCAD, as you can see, I'm gonna just select the line again. I'm gonna change now, in this case, the line, okay? And I'm gonna use a blue, okay, as the, let me just draw somewhere here for clarity purpose, and I want to zoom so that you'll be able to see. If I select this line, as you can see, AutoCAD measures immediately the moment to move up to that point. If I move it up to incline that point, which is the horizontal construction line, so what you need to do is to draw a parallel line parallel to the XY plane, which is 15 millimeters above, 15 millimeters above the reference line. In that line is the line that I've just put on here. This line, okay? But for you to draw it, you will not be able to get that point. So first of all, you have to draw a vertical line to give you the length as you can measure using your straight edge. So in this case, I just want to draw that one. And as you can see, it's 15 millimeters. But in AutoCAD, again, you can hover over there and click 15 millimeters. You select 15 millimeters and press enter. It will snap to that point. Already it has locked 15 millimeters. Perfect. That's it. Now, if you were to draw an horizontal line, you change that one into just a construction line, probably not a hidden line, but let me say by default. Now you select a line, and then now we assume that this is the line that you're gonna draw, which coincides at a point distance here, which is this point. If I draw a circle here for you to be able to see, this is the point here in the middle. Here is the point. This point is 15 millimeters above the reference line. Okay. Now the next thing is very simple. I wanna go a bit faster. So B is 15 millimeters above HP. So its front view, B prime will be 15 millimeters above the XY reference line. So you've got to mark B prime above XY reference line. So from here, where are you going to, sorry, I think I might have erased B prime above the reference line, 25 millimeters. Here it is. Now, the next step, pay attention please. The top view of B, and remember, I said again, when we discussed previously, the things that you need to understand when we talk about, for example, in this case, I've just I've labeled as B in brackets A prime. What does that tell you? It tells you that at a point where you're able to view, you're only able to view what point? B, and this the plan or the top view, you're able to see only point B. But because A is along the straight line here below, it's not visible directly from the point of view. If you're viewing it from where? From the top here. If you're viewing it where? From the top here. Okay. Let me change so that at least it's visible. Okay. Let me select this one and change it. So if I'm drawing a line, I'm assuming the point of view is from this point. Okay. I want to unlock this all the more so I can do just an arrow. Okay. Okay. Let me do that one and zoom it that way and lock it. Okay. And also doing that one. I've just doing something like an arrow. Okay. That's my point of view. If that's a point of view, then we're able to see from the top a point which is down here. That point is B. But because A is vertical down, you cannot see it. And that's why we in engineering drawing, we use what you call brackets to illustrate that point. Yes, coincides with the other. We use brackets. In some other standards, they use a comma, a time without brackets. So pay attention to that one. I want to explain or illustrate that one for your understanding. So in our drawing, because I was just illustrating using this to understand how to measure a vertical line in AutoCAD, it's very simple. So quickly, in the same manner, I just want to show you. You want to draw an horizontal line of say 50 millimeters, just click the line, and anywhere you want to draw a horizontal line, click there at the starting, make sure you lock the auto mode, you draw an horizontal line, and you can see here, check closely, AutoCAD is marking it as 74. As I move backward, it's changing the dimensions, okay? And at any given time, it's very accurate. It gives you, you can increase the decimal points. And if you want 50 millimeters, type 50, and then press enter. That's it. And also another, or double click, or just right click to enter. That's it. And you have drawn that line. If you want to measure that line, and you want to prove that it's what? It's 50 millimeters, just use you can dimension it and click the first end and also the final end. Sorry. Okay. You want to change that one. Sorry. And also the other end, that one, and just drag it up above. You can see it's what? It's showing the dimension, it's showing is what? 50 millimeters. Now I will start showing you how to draw the same way you draw a vertical line in the same manner. Now it was demonstrating and I'm gonna delete it. Now let me go to the next step, the step 3. Okay, so its top view is B will be 25 millimeters below the XY. Now roughly at the orientation, look at the orientation once again. The line is perpendicular to HP. What do we mean by perpendicular to HP? This is what I mean. Perpendicular to HB. It means when you are just able to see that this is HB, HP here down. Line perpendicular to HP, it's meeting at 90 degrees. Like you can see this point. From this point, I want to just demonstrate this one. That point is parallel to that one, but parallel to that one again, down something like this. And you can say that it's what? It's perpendicular. This is perpendicular. That it is meeting at 90 degrees if you measure this one. And if it was in front of you directly, it becomes like this angle. Something you want to pay attention to that one. The line is perpendicular to the HP. Its front view shows the true length. And that's why that true length is able to be read, as in this case now, A, B, but in this case, we are having our line here. A, B. You can see it's a true length. It is the length that we were given as what? Millimeters. So that's the 40 millimeters you want to go above that one. But if you were to project it in this way, now I'm gonna show you when we're gonna use 3D for your understanding. Please pay attention to this one. I'm gonna now use this to show you how we're gonna change that one. Okay, into 3D. In this case, it's gonna change a little bit. Okay, now I'm gonna use like this angle to change that one. As you can see, it has changed the position. And let me change also what we call one moment. Let me zoom it. Now you can see the way I have just changed. Now let me see the top. Now it becomes a plan like a flat surface. When we flattened this one, like this one, we flattened it. Now we are looking from the top view here. It's flattened. It's just like this entire one piece of paper. But if it was a 3D, and let me just change again the position, looking and viewing it from that position, it changes. But if you want just to click, you can just click here home, and it will take you to the 3D view. But again, that's basically what we're just talking about. Orientations when we're using the world coding system and these navigation tools. So, in a nutshell, what do we have here? So the last part was the last step is just for us to draw the true length, which is the front view. So before that, let me just change this very quickly so that you're able to view it. And in that case, sorry, one moment, I've just closed the wrong. Let me just open it. I've just opened it quickly for our learning. Now, the last step was for us to just now do what? So from B prime, you have to draw a vertical line representing the true length, which is B. This one, you draw just a vertical line representing the true length, which is AB. And this one can be seen only from the what? From this perspective, or that direction, is what? When the observer is from this end. It's when we'll be able to view the true length. But suppose we were viewing it from the top, then we'll be able just to see it as just a dot, or just a point. In this case, this is what just I've marked here beneath it. But that point is what, as we just it again, 25 millimeters. 25 millimeters away from the reference line. So point A in a plan coincides with point B, would be, as I just said again. So what you write? We write A equals to B, basically. So what we observe, so I just said again here, front view, A, B prime, A prime, B prime, shows the true length. Let me just project here for you. Here, good. Oh, I just forgot one. I needed to choose a B prime because I'm talking about B prime. In this case, let me just edit this. Sorry, it's visible as such. Quickly, I'm gonna edit it so that it's visible as such. Now, there we go. The top view A, B becomes just a single point. So why is the top view just a point? This because it's just what? It's just what? One moment. It's just the line is perpendicular to the HP. Whenever a line is perpendicular to a plane, its projection on that plane becomes just a point. Notice that we are keeping the length constant at 40 millimeters. This helps to focus on how orientation affects the projection, not the size of the line. So I may have drawn because a line would have just to draw a point would have just required to increase this line length in this case. And so you can see what I did. I just draw basically what like a second field, but it's a line, it's a point for visibility purposes. Okay. Yes. Up to this extent, we can just say that if you are satisfied that, or if you are satisfied with this tone and clarity, then next we can just proceed to when a line is perpendicular to the VP and parallel to the HP. And that brings us to our first orientation, brings us to the end of our first orientation. And I believe that you've gained some insights on how a line is perpendicular and perpendicular to the HP and also parallel to the VP. And first, we want to draw the XY reference line and we are to locate point A. and also draw the front view, which we just drew, and the top view, which we just drew here. The front view is here when you're able to view it from that perspective. And that's it. So in our next example, we'll just be focusing on the same line, CD, 40 millimeters long. It has its end at C, 25 millimeters above the HP, and 25 millimeters in front in the same manner. But in this case, the line is kept perpendicular to VB and parallel to the HP. And that brings us to the end of our session. So if you have anything that you want to raise a question at the comment section, please comment and raise any question that you want to raise to be addressed for clarity purposes. And I believe that we will be able to move forward together. Thank you so very much for your time. Please let me know where you are watching this from and ensure that we move forward. Yes, thank you so very much.